Hello, and welcome to today's lesson on understanding what is meant by pressure. Today, we will cover what pressure is and how it is defined. We will then look at how pressure changes with force and area. Finally, we will briefly touch upon the topic we will delve into next, which is pressure differences in fluids. So far, we have discussed the basic particle model of matter. You have learned how particles in solids, liquids, and gases behave, and how their arrangement and movement explain the properties of these states of matter. With this foundation, we can now advance our understanding by exploring how these particle behaviors result in the concept of pressure. This lesson will help us better comprehend everyday phenomena and will prepare us for more complex applications of pressure in various fields of physics. Let's get started. Pressure is a measure of the force exerted by a substance on a surface per unit area. Mathematically, it is defined by the equation pressure equals force over area. Here's a breakdown of the units used in this equation. The force applied is measured in newtons N. A newton is the SI unit of force, which is the amount of force required to accelerate a 1 kilogram mass by 1 meter per second squared. The area over which the force is applied is measured in square meters. The resulting pressure is measured in pascals, PA. 1 pascal is defined as 1 newton per square meter. So, the pressure unit in terms of base SI units is equal to newtons over square meters. This means that pressure is directly proportional to the force applied and inversely proportional to the area over which the force is spread. A larger force or a smaller area result in higher pressure, while a smaller force or a larger area result in lower pressure. Let's explore how pressure changes with variations in force and area through detailed principles and examples. Let's start by looking at the equation. We can see that as force increases, pressure increases. Secondly, we can see that as area increases, pressure decreases. Let's look at these relationships in more detail. Firstly, increasing force increases pressure. If the area remains constant, increasing the force will result in an increase in pressure. For instance, when carrying a heavy backpack, the increased weight exerts more pressure on the ground, causing deeper footprints. This is because the same force is distributed over a fixed area, leading to higher pressure. Secondly, decreasing area increases pressure. If the force remains constant but the area decreases, pressure will increase. For example, if you stand on the sand with both feet, your weight is distributed over a larger area, resulting in broader and shallower footprints. If you lift one foot, the same weight is now concentrated over a smaller area, increasing the pressure on the sand and leaving deeper footprints. Let's now consolidate our knowledge by looking through some worked examples. Suppose you have a force of 500 newtons applied to an area of 2 meters squared. Firstly, identify the given quantities, and then to find the pressure, use the formula pressure equals force over area. Substituting the values in, pressure equals 500 newtons divided by 2 meters squared, giving 250 pascals. So, the pressure exerted is 250 pascals. Let's try another example. If you apply a force of 1,000 newtons over an area of 0.5 meters squared, what is the pressure? Let's identify the quantities the question has given us. Once again, pressure equals force over area. So substituting in the values, pressure equals 1,000 newtons over 0.5 meters squared, giving a result of 2,000 pascals. Thus, the pressure exerted is 2,000 pascals. For our last example, if a pressure of 800 pascals is applied over an area of 4 meters squared, what is the force? Write out your given quantities to begin with. In this case, we need to rearrange the equation to find force, giving us force equals pressure multiplied by area. Plugging in the values, force equals 800 pascals times 4 meters squared, which equals 3,200 newtons. Therefore, the force applied is 3,200 newtons. So far, we have concentrated on understanding pressure in everyday scenarios. In the next unit, pressure and pressure differences in fluids, we will explore how pressure behaves in fluids, liquids and gases. Understanding pressure in fluids is essential as it forms the basis for explaining phenomena like buoyancy, atmospheric pressure, and hydraulics. To summarize, pressure is the force exerted per unit area. It increases as the force increases and as the area decreases. We can see these principles at work in everyday life, such as standing on sand or carrying a heavy backpack. This foundation will help us explore more complex topics involving fluids in the upcoming lessons. Today, we explored pressure, defined as the force per unit area using the formula. Pressure equals force over area. We discussed how pressure increases with greater force or smaller area, and how it decreases with lesser force or larger area. Practical examples like carrying a heavy backpack or standing on sand illustrated these principles. With a solid grasp of pressure, you're now ready to delve into more complex topics in fluid dynamics. Thank you for joining the lesson.